Hello, good morning, and you're very welcome to this morning's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from today. Today, we're going to be talking about farm level economic, environmental, and transport modelling of alternative feedstock solutions for regional anaerobic digestion plants in Ireland, also known as AD. And we're delighted to be joined by Dr. Fiona Thorne, who's agricultural economist, who's going to be our main presenter this morning. We're also joined by Trevor Donnellan, who's head of the Agricultural Economics and Farm Survey Department in Teagasc. Réamonn Fealy is a researcher in agri-food business and spatial analysis. And Dr. Kevin Hanrahan is head of rural economy. And we have Meabh O'Hagan, who's going to be helping us out with questions later on. Meabh is a climate action and sustainability advisor with Teagasc. So we've a full panel of expertise here this morning. So we do hope you take full advantage of that during our session this morning. And we also have Cathal Buckley here, who is a researcher in environmental sustainability and environmental economics based here in Athenry as well. So good morning to you all. You're very welcome to this morning's panel discussion and presentation. Fiona, before you start presenting, maybe you could tell us a little bit about yourself and maybe how this project came about.
Thanks, Mark, and I'm delighted to be here with you this morning on the Signpost webinar series. So I'm an agricultural economist in the Rural Economy and Development Division here in Teagasc. And for a long number of years now in Teagasc, I've been working on agricultural economic issues related to the crop sector here in Ireland. Many years ago, I looked at alternative energy crops in Ireland. And this project came about because there is a need to understand what the potential implications on sustainability are at the farm level if AD is to reach the targets that we've set ourselves. So this project is funded by SEAI and Gas Networks Ireland, and I'm delighted to present the research findings to you here this morning.
Great, thanks, Fiona. And they are indeed quite ambitious targets that have been set out for AD in the country. So it's really important that we have a solid economic basis for that, and that I suppose we understand those complex dynamics in the background. So, Fiona, if we could ask you to share your screen with us, and while you're doing that, just to remind everybody that today's session is in fact recorded and will be available on the Teagasc YouTube channel later on, as well as a podcast version. And a copy of Fiona's presentation will be available later on also. So, looking good there, Fiona. Yeah, that's perfect. We'll look forward to taking questions afterwards. So, thanks, Fiona.
Good stuff. Thank you very much, Mark, for that introduction. So, as I've already said, Fiona Thorne is my name. I'm an agricultural economist here in Teagasc, and I'm joined by a number of co-authors on the report who will be assisting in the questions and answers when we get to the discussion session. So the title of the presentation is a bit of a mouthful, but what it is that it is the results of 3.5 years' work looking at the economic, environmental and social implications at the farm scale if we are to look at feedstock provision for AD. It's funded by SEAI and Gas Networks Ireland. So just to give you an overview of what I'm going to talk to you about for the next half hour or so, I'm going to start off with a background where we are now with anaerobic digestion, an overview of the situation at present and the ambitious targets that we've set ourselves by the year 2030. And then in terms of the modelling, I'll outline how we went about doing it and the results that we have relating to farm level modelling, looking at economic and social sustainability implications and environmental sustainability implications. Then move on to results from the transport modelling that was carried out as part of the research, the aggregate sector modelling, and where to next with this type of research. So, an overview of the AD situation at present. We have the Climate Action Plan targets, which set out very ambitious targets for the anaerobic digestion sector. We've set a target by the year 2030 of 5.7 terawatt hours production of biomethane, which provides a diversification opportunity at farm level. And the pathway towards that 2030 target is laid out in the National Biomethane Strategy, which was published last year. And that biomethane strategy is very cognizant of EU policies, such as the Renewable Energy Directive, which is important that we abide by the regulations that are set out within that directive. And the National Biomethane Strategy identifies that we'll need not just food waste, but agricultural feedstocks are very important in reaching those ambitious targets. In 2026, we'll see the introduction of the main policy lever that will be put in place to create a demand for this biomethane. It's important to say at this point that the renewable heat incentive, as it's called, or the RHO, is quite different to the policy levers that have been put in place across the rest of Europe. And the RHO is to create that demand for the supply of biomethane. There's also been a capital grant for AD construction. That capital grant was announced last year, and it came from a source of funding from the European Union called Repower EU. That budget was 40 million for the capital construction of a number of case study early starter AD plants. So where we are now, so currently the number of plants producing AD producing plants is somewhere less than 20. It's hard to get a definitive number on those plants, but somewhere less than 20 is the figure that we're coming up with at the moment. These plants are plants of various scales and various end uses. The majority of them are combined heat and power plants, and only a very small number of them are actually producing biomethane. And I'll describe what the difference is in those type of plants in a few minutes. But the targets that we've set ourselves to reach that 5.7 terawatt hours of energy will mean that we'll need to move from that currently less than 20 to 150 or 200 new plants by 2030. So very ambitious targets there. And to meet that target, we'll need significant capital investment costs, and we estimate them to be around 1.5 billion, and then additional ongoing operational costs of about 300 million per annum. Feedstocks come in from the ag sector, grass silage, about 1.3 million tonnes of grass silage and 7.5 million tonnes of slurry will be needed to reach those targets. And the agricultural land necessitated to reach the targets, about 120,000 hectares. But we talk about a sensitivity around the number of hectares that will be required later on in the presentation. So that's the overview of AD. But talking about the actual physical process itself, here in graphical format, we have the anaerobic digester here in the centre of the graphic, and we're looking at feedstocks being fed into that anaerobic digester, and that feedstock can come from process food waste, it can come from slurry, it can come from silage. And then out the far end of the AT process, you produce biogas, which can be upgraded then to biomethane and carbon dioxide. And that biomethane then can be used as injected into the gas grid or used in the transport sector. The other output of the AD process, which I haven't talked about so far, is the digestate that's produced. And in a circular bioeconomy system, in an ideal world, that digestate then is returned to the land that is used to produce the feedstocks for the AD process. So that's AD in a nutshell. Now, moving on to the results of this project, and I'm going to start off with the farm level modelling results, talking about economics, talking about social sustainability, and talking about environmental sustainability. So how do we go about looking at economic sustainability in this project? And when I'm talking about economic sustainability, I'm talking about the profitability at farm level. If farmers were to look at growing silage for a regional AD plant, as opposed to doing what they're already doing at the moment, whether it's rearing beef animals or rearing lambs in the sheep sector, or compared to the profitable dairy sector or the tillage sector. So this is what this bioeconomic modelling chapter in the final report was about. It was looking at those trade-offs. In terms of the feedstocks for the AD process, we looked at two different types of feedstocks. We looked at data from the National Farm Survey for farmers that are producing perennial ryegrass silage, and looked at the cost of production within that data set. And we also looked at data from the Grange feed cost model from colleagues in Teagasc and Grange, where they model the cost of production on an annual basis of different feedstocks. So here we're also looking at the cost of production of perennial ryegrass with red clover as a feedstock into these regional AD plants. And then we constructed this bioeconomic model in Microsoft Excel, and we had what we call a baseline enterprise. So that's all I'm talking about there really is the existing farm enterprises that we have within Ireland. And looking at the profitability of those systems and what would happen if you got rid of a hectare of that land, whether it's rearing the cattle or producing milk or producing crops. And instead of doing what you were always doing, you got rid of that production and you then grew perennial ryegrass for silage for the AD process or a red clover mix going into the AD process. We didn't look at different business scales. We didn't look at whether it was an AD process at farm level or outside of the farm level. We abstracted away from that, and what we were interested in was the economics of producing the silage. Okay, and the results that I'm going to present to you here in the next slide is the results of the perennial ryegrass and red clover scenario. The data that I am using here is somewhat outdated. When we started off with this chapter in the report back 3.5 years ago, and the data that we had was from the National Farm Survey from 2018 to 2020. It is currently been updated at the moment. But we looked, as I said already, at data from the National Farm Survey. We looked at perennial ryegrass costs of production for the years 18 to 20. We excluded land rent or land charge, and we excluded any additional capital expenditure relating to silage pits and also the red clover mix. So that was based on 3 cuts of silage per year, 14 tonnes of silage production. And we assumed that 42% of the digestate would be reused on this red clover crop. An additional P&K fertiliser was applied to balance the offtakes. Not all of the digestate we assumed was applied to the red clover crop because it wasn't necessitated because of biological fixation. So the digestate that wasn't returned to the red clover crop we assumed was used elsewhere on the farm. And an opportunity cost associated with that digestate was included within the model. Okay, so what does it look like in terms of economic sustainability with existing farm enterprises? So we're looking at individual farms. If they get rid of a hectare of land, say on the beef rearing, cattle, other, sheep, tillage or dairy farm, if you get rid of what you were already doing for that baseline period of 2018 to 2020 and grew this hectare of perennial ryegrass for a regional AD plant, what we're looking at here is the economic situation. On the dairy, on the right-hand side, we see all the bars are below the line. So if the farmer got €30 a tonne, €35 a tonne, or €40 a tonne for the silage, it doesn't make sense for the dairy farm to convert to growing silage for the AD plant. But across the other systems, the story is mixed, and it really depends on the price point of the silage that was being sold to the AD plant. So for the period 18 to 20, you'd need at least €35 a tonne, if not €40 per tonne for it to be economically viable in the other sectors, particularly in the dry stock sector. If you're getting €40 a tonne based on the economics that we carried out, the dry stock sectors would be more profitable growing the red clover crop for the regional AD plant. Okay, but we know the cost of production of grass production, of silage production has increased significantly since that baseline period when we carried out the work. And we also know that the income on the individual farm systems has also shifted in the intervening period. So here in this slide, I just want to show you a quick take-home message in relation to how costs of production of silage have changed, and also on the other side, how the income on those superseded enterprises has changed. So you see significant increase in cost of production of silage on the left-hand side of this graphic as you move from 2018 to 2023. And also the income on the right-hand side here, we're looking at family farm income per hectare, excluding direct payments for our main farming systems. And we see that the income levels have shifted over time. So just reinforcing the point that there is a need for ongoing research in this area and for an updating of the figures based on the bioeconomic model that we've already constructed. I also said to you at the outset of the presentation that I talk about social sustainability. And when I talk about social sustainability, what I'm talking about really at the farm level anyway, is willingness of farmers to adopt these new farming practices. So what we did here was that using the National Farm Survey, our recorders went out into the field to our 1,000 farms, which are weighted up to the population to represent the population of farmers that we have out there. And we asked them a various number of questions relating to their willingness to engage in providing feedstocks for a regional AD plant. And you see the questions there in the graphic. We asked them their willingness to supply silage, to produce low nitrogen silage, so that's your clover, to supply slurry into the AD plants, to receive the digestate back from the AD process, or join a cooperative looking at forming an AD in the local area. So overall, I'd say that this particular piece of research is showing us overall there was low levels of willingness to engage, below 20% in most of the scenarios. The one which was somewhat different was the receive and digestate. So here we're seeing that farmers were more willing to receive the digestate out of the AD process than they were to supply the silage. So obviously they're providing a value to the organic fertilizer in this situation. Even though I'm saying low levels overall, it is important to note that we're not talking about very, very significant hectares of land being needed for this AD process. And at willingness levels, just below 20% across the different feedstocks provisions, I'd say that those levels, if each of those farmers actually went ahead and engaged in supplying the feedstocks, those levels of engagement would be sufficient to achieve the 5.7 terawatt-hour targets. Okay, so that's the economic modelling. What about the environmental modelling and the greenhouse gas emissions that could potentially be abated as a result of growing silage or supplying slurry to a regional AD plant? So in this economic and environmental modelling, what we did was that we used National Farm Survey sustainability metrics and applied some scenario modelling to those metrics. In terms of providing grass as a feedstock, in the modelling, we looked at 4 separate scenarios. In scenarios 1, 2, and 3, there was varying different usage rates of the digestate. To start off with, we were using a perennial ryegrass and red clover sward, with use of 0% digestate, then 42% and 100% digestate. And scenario 4 was looking at digestate with protected urea. All of the analysis was conducted on a per hectare basis, so we weren't looking at it on a whole farm basis. It was just looking at what the impact would be on an individual hectare of land. All the livestock was removed from that individual hectare of land, and because the livestock was removed, all associated emissions with that livestock was removed. So emissions associated with enteric fermentation and manure management. So that was the grass feedstocks that we looked at, and we also looked at a number of scenarios where slurry was supplied as a feedstock. And in those slurry feedstocks or slurry scenarios, we used a number of different fertilization scenarios. So looked at incorporating protected urea, looked at using digestate and using clover then as your nitrogen fixer. And all the manure management and emissions were removed in these slurry scenarios. So what are the results looking like? So taking back to those grass scenarios that I specified on the previous slide, when we use grass as a feedstock for this AD process, the results of the environmental modelling is showing us that there was between a 50 and 98% reduction in greenhouse gas emissions on a per hectare basis when the livestock was removed. And that's a very important point to remember, that we are assuming that all of the livestock activity is removed in this scenario. So it eliminates methane, and it eliminates greenhouse gas emissions associated with manure management. The scenario where biological fixation of nitrogen was the main supply for crop growth shows the largest reduction in greenhouse gas emissions. So that was the grass-based scenario. What about using slurry as the feedstock? When we looked at using slurry at farm level to feed this AD process, we found that there was between a 6.5 and an 11.6% reduction in greenhouse gas emissions in these scenarios. Significantly less than the greenhouse gas emissions that we've seen in the grass scenarios previously. And this is driven by the reduction in emissions associated with storage and land spreading of slurry. And again, when biological fixation of nitrogen in that scenario, that indicates the highest level of reduction in greenhouse gas emissions, but no livestock got rid of in these slurry feedstock, so significantly less reductions in greenhouse gas emissions when slurry is used as a feedstock as opposed to grass. Okay, I won't go through this slide in detail, but it's just showing the figures that you'll find in the final report across the different farming systems that we have in the National Farm Survey, across the different scenarios that I've already talked about. Okay, moving on to the next chapter of the report, which is the aggregate sector modelling. So what we've talked about already is economic sustainability, environmental sustainability and social sustainability, all at the farm level on a per hectare basis. But what we're going to do here now in the next few slides is talking about aggregating up those impacts on a per hectare basis and what the aggregate impact would be in terms of economics and environmental implications of a regional AD plant. So just a little bit on the methods and how we went about doing this. So we used the FAPRI Ireland model, which is a long-running aggregate sector modelling looking at the impact of different policy changes. So we generate on a regular basis a baseline projection for Irish agriculture, and we're using the baseline projection out to 2030 for this assessment. And over and above that baseline, we simulated 3 separate alternative AD scenarios. Those 3 separate alternative AD scenarios was based on the amount of land that was required to meet that 5.7 terawatt target that I talked about at the outset of the presentation. The 3 land scenarios that we're talking about is 110,000 hectares, 120,000 hectares and 130,000 hectares. And the sensitivity between 110 and 130,000 hectares is related to the uncertainty that we have around the dry matter yields of the silage. So that's why we did sensitivity analysis on the number of hectares. So what happens in this modelling exercise is that agricultural land is diverted from beef production to use in growing feedstock for AD. And the analysis looks in terms of economics at output, input and income in aggregate in agriculture. And then for agricultural greenhouse gas emissions, we're looking at the environmental sustainability impacts at an aggregate level. So wider economy impacts of AD industry development are not assessed in this modelling exercise. Some of them can be positive and some of them can be negative, but we're talking about those economic and environmental impacts, particularly to do with agriculture in this modelling exercise. So a little bit more on the assumptions that we use in this modelling. So previous to this project, in the FAPRI Ireland aggregate model, we didn't have an activity related to AD biomethane. So now we've introduced that into the model so we can look at modelling of specific targets going forward. The AD scenarios were increasing the amounts of land diverted from beef to AD across the different scenarios that we looked at. But it's important to note that the stocking rate per hectare under the AD scenario stays the same as the baseline. So we don't have a change in the stocking rate associated with the different scenarios. So we're looking at a reduction in suckler cow numbers and their followers in this analysis. all pig slurry, and 8% of the cattle slurry is used by the AD industry. Farmers are not paid for the slurry, and they do not pay for the digestate that they receive back. And the grass delivered to the plants, we assumed, was paid at a price of €55 per tonne. Other outputs and input prices used in the scenario remain at the baseline levels. So what are the results looking like? Relative to the baseline, the use of grass and animal slurries to achieve the 5.7 terawatt-hour targets in general increases agricultural sector income and decreases agricultural sector greenhouse gas emissions. The increase in the sectoral income out to 2030 comes from three different sources. It comes from cattle output value decreasing. The output value of grass goes up as it's fed into the AD process, and input expenditure associated with the rearing of the animals declines. By 2030, agricultural sector income is projected to increase between 1.2% and 1.3% across the different scenarios, which is between 49 million and 53 million euros by 2030. And that's equivalent to an income of approximately 425 euros per hectare on the land that's devoted to AD. And on the environmental emission side, in an aggregate sense, greenhouse gas emissions are projected to be 2.3% lower, and that's emanating from methane emissions reductions by 1.8% and nitrous oxide emissions down by 4%. And important to note that the impact of biomethane in the reducing energy system greenhouse gas emissions is not accounted for in this analysis. We're particularly looking at the agricultural greenhouse gas emissions and the modelling of that going forward. So the final research chapter that we looked at was transport modelling. And in the transport modelling that was carried out in the analysis, we used the geographical information systems, a particular a component of that called network analysis. And what that GIS modelling system did was that it located potential AD facilities to the maximum that's required in the 5.7 terawatt-hour target. And while maximising the achievement of the target, we were also looking at minimising transport distances required for the feedstock access. The data that was used in this analysis was based on DAFM's LIPA's parcel data in terms of the feedstock provision, and then the road network data was sourced from Tailteann Éireann, previously Ordnance Survey Ireland. We've talked a lot about scenarios so far in the presentation today, and I've just another two scenarios I want to talk to you about here. We had a middle optimistic scenario and that we modelled, and also a pessimistic scenario. In the middle optimistic scenario, what the modelling did was that it assumed there was surplus grass available, and that surplus grass was then looked at to reach the target of 5.7 terawatt hours. And in the surplus grass scenario, the feedstocks supplied into the plants was available from within a 10-kilometre road distance of the plants. Whereas when we looked at the pessimistic scenario, we weren't assuming surplus grass, but we were assuming a ceiling of 15% grass availability from individual farm levels, and looking at the road distances then to the individual plants. And in this pessimistic scenario, the provision of feedstocks from 10 kilometres wasn't sufficient, and we found that you needed to move to a 15-kilometre radius to achieve the targets. This is just a graphic here of some of the graphs and the maps that are available within the final report, and showing the distribution of the AD plants and that we projected, and the road distances required to provide the feedstocks. Okay, so conclusions from the research. Relating to economic sustainability, for some farmers it can be economically viable to supply silage to the AD process, and it very much depends on the starting system that you're looking at. But also we need to be cognizant of the cost movement and the price point at which the silage is sold into the AD process. Inertia at farm level can't be overlooked, and the ability and the willingness of farmers to look at changing system, we need to be aware of that. So that's at the farm level, but what about the aggregate level? We found that the aggregate level benefit in terms of economic sustainability are not very large, as the land used is relatively small and the additional margin over the alternative enterprise is also small. What about environmental sustainability? Again, we looked at it at the farm level and at the aggregate level. We found that supplying feedstock, sorry, now I move slides now on you. We found significant savings on a per hectare basis at farm level in relation to environmental sustainability, but at the aggregate sector, the reduction in agricultural emissions in the inventory is not very large. And I'd say there that even though it's not very large, neither are many of the other measures that are included in the marginal abasement cost curve. So it's a piecemeal approach that we're looking at with individual technologies contributing their own part to ag emissions. And finally, social sustainability, I'd say broader awareness is crucial, and we found that when we conducted the survey through the National Farm Survey. But I would say that even though willingness level didn't appear very high, from the levels of interest, it did seem that if those individual farmers did go on to supply feedstocks, we would have enough farmers to reach the targets that we have set. So where to from here, and what are the research gaps? In relation to economic sustainability, there is a need to look at scale of these AD plants, whether it's farm scale, regional scale, or larger scale plants. We haven't looked at that within this research, and it's something that we'd like to do in the future. We also need to look at the economics of alternative feedstocks. We've only looked at a limited number of feedstocks in this analysis, and also need to look at the economics sustainability under different cost and price scenarios. And what are the research gaps relating to environmental modelling and sustainability? It's all about incorporating new data into the modelling process that we've already established. Social sustainability, we've really only looked at it so far in terms of social sustainability at the farm level, but there is definitely a real need to look at social sustainability across the wider community. Also, a need to update the transport and aggregate sector modelling that we've already established in this project. We do have new funding sources in place at the moment to undertake and continue on this research. And in early 2026, we'll be looking at alternative business models of AD and focusing on alternative feedstocks and model updates. So that is about it from my side. I'm just finishing up here with an infographic which summarises the results from the main chapters of the report, and the report will be available on the Teagasc website in the coming days. So that's it from my side, Mark. I'll stop the share perhaps at this stage and we can go on to the questions and answers. Thank you.
That's great, Fiona. Thanks so much for that. And it's great that you're joined by colleagues as well who contribute to the paper. So we have the full team here that can answer those questions. And look, we can throw the ball in there. I mean, look, there's been a lot of discussion in Ireland and planning and thinking about AD, but like 20 plants is still, it's a relatively low uptake. What needs to happen next based on the research that you've conducted, Fiona, and others feel free to chip in on that one as well.
So Mark, you're right, like they're very ambitious targets that we have set ourselves. But look, we do have the National Biomethane Strategy, which is a very important document that was published back in 2024 and essentially lays out a roadmap for the different things that we need to do to ramp up to that 5.7 terawatt hour target. They're multifaceted. There's things that we need to do in terms of planning. There's things that we need to do on the capital side of it. There's research gaps, but probably one of the important first stages in it, Mark, is the rollout of the demand for the biomethane that's produced. So the heads of bill for the legislation for that renewable heat obligation, the RHO, is expected in 2026, and that's essentially what the industry is waiting on at this stage, is to create the demand for these plants. We can set the targets as much as we want, but we need to be able to match the supply of the biomethane with real hard demand for it. And that's what the RHO will do when it is rolled out in 2026. We do see developers around the country still going ahead with planning. Some of them are coming to fruition in terms of construction, and that from grant aid from Repower EU was important in doing that when that was awarded last year. But the rollout of the RHO will really be a game changer in this regard, Mark.
I noticed in your slides there the income for the beef sector for in the
Yeah.
last couple of years is starting to increase, which is, I suppose, welcome for that sector.
Mm.
What sort of an impact do you think that's going to have in terms of that appetite
Yeah.
for supplying silage or grass to
Yeah.
AD
Yeah.
plants if it
Yeah. So
continues?
yeah. So look at it. There's definitely a real need to update what we have at the moment. That was based on data. The results that I showed you there, the farm level economic modelling was from data from the National Farm Survey from 2018 to 2020. So on one side, the cost of production of the silage have increased over the time period, but likewise on the other side, the incomes from the dry stock sectors in particular have increased. So I think that it's important to update the cost of production to look at realistic price points for the silage out of from that side, and likewise on the income side. So that has to be matched up, and that is something that we are going to be starting early in 2026. Matching up the income changes with the changes in the cost of production and the price point.
Okay, great. That's great, Fiona, and encourage all of our panelists to chip in as you would like. I'd like to have a conversation around this as much as we can. Maybe some interesting questions coming in from our audience. Actually, a lot of interest in this topic this morning. A lot of people on interested to see where this is headed.
Yeah, the questions are starting to come in thick and fast there, Mark. But in particular, a lot of interest around the transport modelling in terms of I suppose how that research was done with the modelling of the location allocations, and then also kind of some specific questions in terms of like quantifying how much increase in local transportation would this cause for our local community and stuff in terms of that social sustainability side of things and getting people to buy into it. So I don't know if one of the panelists could comment on both sides of that.
Sure, Maeve. That was my particular area of contribution to the project. I'll start with a very brief comment on what the actual network analysis is. It's a spatial optimization tool that can be found in some of the higher end geographical information systems. And basically what it does is it takes a quantity of demand, or what's termed demand. In this case, it's the availability of grassland and storing, and it allocates it along a network, a road network in our case, and it's the actual real road network as mapped by previously Ordnance Survey, now Taltair. It assigns that quantity to your supply locations then, which are in this case the anaerobic digestive facilities. And it does that in an optimized fashion. So basically you can tell the algorithm to optimize for distance or optimize for speed. And there's a whole range of parameters that you can put in there, like size of vehicle, etc. So it's a very, very powerful tool, and it's become increasingly accessible, I think, over the years, because it's algorithmically, it's a very high resource. It's in a high IT resource application. Modern computers let you do that quite quickly. So some of the model runs we're doing here, you can do in less than an hour or two, whereas 8 or 9 years ago, that was taking 9 or 10 years. To get to the actual question around, did we model for the increase in vehicle transport? We didn't specifically, but it is something that could be derived from the analysis, in that we take the gross amount of feedstock supply for an anaerobic digestive facility. And then if you like, you could actually disaggregate that out into a load quantity, which will give you the amount of vehicle traffic if that was required.
Okay, yeah, I guess it is just going to be it's an important thing, I guess, amongst communities, like that there has been obviously concern around these things coming up in the area, and it's important to keep everybody on side if we're going to achieve the targets. Another question there that was, a couple of questions were kind of coming in terms of, Fiona presented the economic impact and how it maybe more financially makes sense for smaller scale farmers, beef farmers and stuff like that. So just wondering then, in terms of what's going to be required for some of those maybe less intensive farmers to be able to produce the grass feedstock necessary to feed these plants, will there be additional labour required from that point of view, or would it be suitable for part-time farmers? Would it require a lot of on-farm investment in terms of reseeding and stuff like that? And what sort of an impact would that have on those farmers?
I might have a go at that. So what we're looking at, we two feedstocks going into it. Okay, so we're looking at perennial ryegrass as it is grown currently within the National Farm Survey, and then looking at incorporating red clover into the mix because of the environmental credentials associated with that. Like, we have to be governed by what the Renewable Energy Directive specifies, and growing high intensive grassland with additional chemical fertilizer is not what we're talking about here. We're talking about biological fixation and using that as your nitrogen source. But those questions around sort of the business case and the whether it's a farm scale AD process or a regional AD process, that's what we want to do in the next stage of this research. We weren't looking at that in this particular research. We just assumed a modelled crop of red clover, and it had average costs of production for red clover, but we know that there is a distribution around that. So it's all those sensitivity analysis that we'd like to look at in the next stage of the project. But I think that question came in, whoever that came in from, I think they're hitting the nail on the head between the differences in the economic potential and advantages for whether it's low intensive dry stock type farmers compared to our more intensive dairy farms, where we saw that the economic viability wasn't in it. But matching up where those farms are with the demand for the individual sites and where they're located will be the next stumbling block in it all. But look, I'd say a lot of work done in this project, but there's definitely research gaps and more work to be done on it from here, Meabh.
I might just come in at that, if I may. And I'd like to acknowledge Maurice Deasy, who was the main person who was researching on this project. We looked at the kind of grass tonnage grown on currently on silage across different farm systems, and dairy farmers were at over 15 tons in terms of the silage yield, and the non-dairy farmers, dry stock, were about 12.5. So they're not a million miles away from what 14 that Fiona is currently talking about, and it's not a major change of land use in terms of what they're used to. And in some cases, it actually would be a reduction in labour because they're not having to, I suppose, tend to livestock. It's more of a narrow based system.
Yeah, that's great, call. I think just like a couple of points there that are kind of standing out to me, coming in from the questions as well, is from a financial point of view, there does seem to be benefit there, but maybe work to be done in terms of the knock-on effects from, I know there was questions coming in there about water quality as well, and the impact that it could potentially have on that. But as well, questions coming in terms of like that the economic and environmental aggregate benefits seem to be maybe smaller than people were expecting. Do you think that when it's applied on a national scale, like are we expecting those figures to grow as the sector grows, or is that kind of us maxing out the potential for the sector here?
Meabh, yeah, I mean that's a good question, and it's one we pondered as well when we got to the end of our aggregate level analysis. And so what we're assuming in the analysis is that over the period to 2030, we in a kind of a stepwise fashion achieve the 5.7 terawatt hours, and we don't go beyond that. And that basically limits the big macro impact of this on agricultural sector income, and also on the the scale of the reduction in greenhouse gases associated with agricultural activity in aggregate. It's, you know, if the economics were right or powerfully positive enough, you could imagine farmers growing more than choosing to grow more grass for feedstocks if the industry demand was there. But the assumption is that in our analysis that we didn't go beyond the 5.7 terawatt hours. And while 120 or 130,000 hectares seems like an awful lot of land to switch out of producing food like beef into producing grass feedstocks for the energy system, in the scale of the overall UAA in Ireland, it is still a relatively small proportion of the overall ag area. So the impacts on agricultural production and on the impacts as a consequence of that on the emissions from agriculture in terms of greenhouse gases are also relatively small. Now, why might we not go beyond 5.7 terawatt hours? That comes back to what the outlook or what the desired composition of the future energy system is. And in some sense, there's a desire not to have an energy system in the future that's based on fossil fuels and things like biomethane, which are substitutes in a kind of an energy system that's based on burning stuff as opposed to using solar or using wind. So in some sense, the people who are setting these targets want to target that creates a diversification opportunity for agriculture and contributes to the decarbonization of the energy system. But in some sense, they don't want to build in capacity for this fossil fuel based energy system way into the future that would be there if people were encouraged to invest an awful lot of money into plants that were capable of supplying many multiples of that 5.7 terawatt hours target. So it's a kind of a balance between creating a diversification opportunity for some farmers, helping to decarbonize the system, but at the same time not creating a legacy in terms of infrastructure that basically encourages the perpetuation of an energy delivery system that's based on burning stuff, biomethane or oil or liquefied natural gas. So it's possible if the economic incentives are right, but our analysis just focused on delivering the national target that the biomethane strategy has set.
Yeah, and just a follow-up question maybe on that, Kevin, as well, a question that has come in terms of like how does that 5.7 terawatt hours compare to the natural gas usage within the country? I guess how much of an impact is it going to have on the decarbonisation of our energy systems?
I would say it's pretty small off the top of my head. I don't know the terawatt hours generated from the burning of natural gas, but I'd say it's many multiples of that total.
Yeah, but I guess it does come, sorry, it just comes back to that point that Fiona said, is that it's, you know, it is a piecemeal approach and kind of combining all of the work that's being done in a number of other areas. You know, it's the combining all of those small differences that's gonna make a difference in the grand scale of things. Yeah, I'll just yeah, go on ahead.
Yeah,
Sorry.
I'm just thinking there's probably people watching on this morning wondering why do we need all of this research given that AD is so popular in other countries, and can we not piggyback on a lot of that research? But Ireland is different to many other European countries, the agricultural makeup. It might be just worth just commenting on that.
Yeah, I might come in there on that, Mark. So look, you're very much bang on the mark there. Like a lot of other European countries have moved ahead over the years, and we are at a low starting point. But I always say when this question comes up is that there is significant learnings for us in that. I talked about that Renewable Energy Directive. There was a Renewable Energy Directive 1, there's now a Renewable Energy Directive 2 and a Renewable Energy Directive 3 coming on stream. And the reason those policies were put in place was because of learnings that have happened about how AD was rolled out across Europe. Like maize was a significant feedstock, and intensive maize production was a big feedstock provider when AD was in its infancy across Europe. We're talking about a different AD process here in Ireland. We're talking about producing it off grass, which we're really good at growing cheap grass, and using slurry as a co-feedstock as a waste into the process. So it is a very different process because of the type of agriculture that we have in the system. You can look at it as a negative that we are at such a low base in terms of using biomethane to contribute to our greenhouse gas emissions abatement. But I'd see it as a benefit that we can learn from how the rest of Europe did it, and that we will be producing biomethane, which is much more sustainable from an environmental sustainability perspective. And from an economic sustainability perspective, why we need this research. We need this research to answer the questions for farmers why they would engage in using this as a diversification opportunity. You need to answer the questions for farmers. Look, am I going to make more money out of it? Am I going to be able to wave the flag and say that I'm reducing my greenhouse gas emissions associated with it? And likewise, social sustainability. What's this going to give me for work-life balance? And we've touched on some of those issues already in the discussion about the intensive nature versus the extensive nature of some farmers. Could part-time farmers do it? Could older farmers engage in this as an opportunity, a diversification opportunity? So I hope that answers your question some bit on that, Mark.
Thanks,
I'd like to comment on the question that Meabh raised about the water quality element and digestate. A lot of issues around digestate, but digestate, we model this in terms of the slurry scenarios at the end, and digestate, you're getting a more homogenized NPK coming back, or a PK coming back out of the process. So it should be easier to match with crop demand, and it's a resource allocation problem. So with soil tests, what the crop demand is. So we're seeing a reduction in balance actually by using digestate versus slurry, because it's more homogenized and you know what you're doing.
Okay, that's great, Carl. It allows for a better targeting maybe of those nutrients to areas that actually need it.
It's probably equivalent to more bag fertilizer than it is the slurry, because it's more homogenized.
Yeah. There was just a couple of questions there, maybe around the modelling of the different total areas of land contributing to anaerobic digestion, and maybe just a comment on why the different levels of land were used in the different models, and then also just tying that in with how do we manage the communication around the messaging of, this much land going towards anaerobic digesters or feeding anaerobic digesters, and making sure that that message doesn't come across as maybe a negative of ground being taken away from farmers, but actually that this is an opportunity, coming back to what you were saying there, Fiona, like this is actually an opportunity for farmers to get involved in this system and maybe have a little bit more income coming in for the farm. So yeah, a kind of two parts to that question. If someone wants to come in on that.
I may take that one. So the different areas that we used were purely because of the uncertainty around the grass yield that could be achieved. So that was a way of trying to address the uncertainties there. So it was a form of sensitivity analysis, if you like, really. On the messaging, I mean, in the end here, what we envisage is that farmers are going to be involved in this. So farmers are going to be growing the grass for the AD plant ultimately. So it's still an activity that's taking place on the part of farmers. It maybe doesn't fit with the traditional definition of agriculture, but I don't think that's a reason purely to dismiss it out of hand. Ultimately, it would be quite dispersed around the country as well. So, I mean, if this was all a super concentrated activity happening on one area of the country, then I guess you could see why people might have some concerns about the implications it might have for the land market in a locality. But overall here, this is a small amount of activity considering the overall land area in the country. We have 4.5 million hectares of land, and this is 120,000 hectares we're talking about in the end.
Yeah, I think it's just so important that we build maybe on our within knowledge transfer, just make sure that we're communicating the message around the opportunity that's presented there to farmers. Like you said, Trevor, like it is an it's just maybe a non it's just a new type of farm, and it's a different type of farm, and maybe from what they've considered active farming before. So it's just to maybe diversify our thinking in that way. Yeah.
Yeah, no, it's a good point. All right. Yeah, there is change required there. A few questions coming in around how AD compares to other renewable sources there. Comments there in relation to solar. I'm not sure is how accurate that is now, but it's saying that it is from an energy point of view more productive. I think that's what the point was
Yeah.
making there. But I guess there'll always be a requirement for natural gas. So maybe that's the point, isn't it?
Yeah,
We,
Mm.
go on,
go on
Fiona.
ahead, Kevin.
No, it's just about I guess we don't want what our energy system modelers tell Trevor and I when we talk to them is that they definitely don't want an energy system that is super concentrated on one source. And one of the challenges we have as we decarbonize the energy system and move to more wind and solar is that sort of point in the year. And as I look out my window here, it's very dark, and at the moment it's not blowing very much wind. So how do we get energy, electricity to people when we don't have any sunshine and then wind isn't very strong? So we need to have elements within our energy system that can be that can come online when needed, and biomethane could be a little part of that, as well as other possibly legacy uses of fossil fuels, or in the future battery storage of energy from times when the wind is blowing and the sun is shining. So we need a diversified energy portfolio, I guess, and biomethane is a small part of that future portfolio that the country needs to be able to guarantee to its citizens that when they turn on a switch, that they can have electricity supplied to them. So it's
Yeah.
not talking about switching to an energy system that's stacking up on agricultural land exclusively, but the agriculture sector is providing a small part of that mosaic of different sources of energy that we will all be using in the future.
Very good. A few questions more on the technical side of AD, which I don't think we will be able to cover this morning as such, but we will. There are previous webinars that have covered off on that topic, so please do take a look at that. There's a question there about the displacement of is it possible that this is going to force emissions to other parts of the globe? For example, a farmer commits to produce silage but intensifies beef or dairy production on the rest of his farm, necessitating the importation of feed from other parts of the world. That's has that
So
been considered?
in our analysis, we assumed that didn't happen, and that, as Fiona was talking about how we did it at the aggregate level. We said, okay, we divert land away from beef production, and we assume that the stocking rates on the remaining agricultural land don't go above what we project in the baseline. So that by construction means that as land is lost to agricultural activity contracts as opposed to intensifying. But the carbon leakage issue is a real one, and economists have been sort of grappling with this issue on an ongoing basis, and it really does depend to a great extent on where the alternative source of supply comes from and what footprint it is. And so Cahill's work has shown what the footprint of Irish agricultural production is, and we can compare those footprints with equivalent ones from other countries. And while we're relatively low and probably comparable with lots of other Northwestern European production systems, there are parts of the world where some of that supply might be coming from in the future. If we reduce our production, that might have a higher footprint. So it's a point, but I guess it doesn't mean that all of the emission savings are gone in aggregate. But yeah, the carbon leakage is an issue, and to really solve agriculture's contribution to global warming, I guess you have to start to think about changes in the demand for the things that we currently like to eat that are associated with greenhouse gas emissions. And this scenario about AD doesn't change that story very much.
On that point, Mark, also, like, we model on the environmental side that animals are being removed, But if, example, animals were just intensified on the remaining portion of the farm and a portion carved off for AD, then your emissions are actually probably going up, like, and your water quality risk is probably going up as well in terms of transfer. So, we have to be aware of the law of unintended consequences here as well.
And the scale of the economic benefit might also be slightly reduced because you probably have higher costs of producing those animals in a more intensive fashion. So some of the benefit in the aggregate sector modelling comes from the fact that you don't have to spend money on fertilizers and veterinary costs and feed because there's fewer animals to be farmed. But there are always unintended consequences and things you need to think through about what might happen if you made a different assumption.
Great. Well, look, we look forward to the full report being published on the Teagasc website in the coming days. I think, Fiona, you said it was going to be available. So we that will be available to you can just I'm sure there'll be some front links on the homepage around that.
Yeah. So early next week, Mark, it'll be up online.
Brilliant, brilliant. Okay, well, look, I want to say a big thank you, Fiona. Thanks for your presentation. Kevin, Cathal, Trevor, Réamonn, thank you for also fielding questions this morning. And Meabh, thanks for helping out with the questions. It's hard to believe it's the 5th of December, toy show night again. So the years are rolling by. I don't know where they're going, but we hope you have a nice weekend. And do join us next week. We're going to be joined by John Noonan, who's an organic advisor with Teagasc, and he's going to be speaking to us about the learnings from farmer networks and advancing organic farming. It's a European innovation project. So we look forward to hearing from John next week. So until then, have a nice weekend and stay safe. Thank you.